Welcome to this video. In this video we're going to talk about the physiology of the thyroid gland. So let me give you an overview of the different things that we're going to discuss in this video. So we're going to start off by doing a basic overview of the thyroid gland. So we'll talk about the anatomy of the thyroid gland, the histology of the thyroid gland. We'll then talk about the different hormones that the thyroid gland secretes. So we'll talk about the two main ones, T3 and T4, which throughout the video we'll just refer to as the thyroid hormones. We'll also mention calcitonin, but I should say right away that this video is not going to be on calcitonin at all. We'll just mention it. We will focus completely on T3 and T4. Then what we'll talk about is overall what role these two hormones, T3 and T4, the thyroid hormones, are actually going to play in the body, and what's the nature of the secretion of T3 and T4 by the thyroid gland, i.e. it's continuous, is going to be one of the main initial lessons that you're going to have to take. It's not the case, as with other endocrine systems, that in response to a certain condition, loads of the hormone is suddenly released. No, the thyroid gland just continually releases T3 and T4 at a set level. Okay, so after the basic overview, we'll then go into things in detail. So we'll go into the synthesis and secretion of T3 and T4 in a huge amount of detail. We'll then talk about the peripheral actions of T3 and T4 in a huge amount of detail. And then finally, what we'll talk about is the control of the release of T3 and T4 to maintain a constant level of it within the blood, i.e. we'll talk about the hypothalamic pituitary thyroid axis. Okay, right, so that's an overview then of the different things that we're going to discuss within this video. So let's begin with the overview of the thyroid gland. So to begin with, we're going to discuss the anatomy, firstly the gross anatomy and then the microanatomy, the histology. Okay, so the gross anatomy firstly. So you have one thyroid gland, and it is located in the centre of your neck, in front of the thyroid cartilage, which is part of your voice box, or more correctly, your larynx. Okay, so if you want to be able to locate roughly where the thyroid gland is, feel in your neck for your Adam's apple, which is caudolaryngeal prominence, and that's a forward prominence of the thyroid cartilage. Okay, that should be in the midline, and then either side of that, the thyroid cartilage will continue on, and in front of that thyroid cartilage, that's where the thyroid gland is. So if you palpate around there, you'll be palpating your thyroid gland. Okay, so let me just draw a little picture then of the thyroid gland. So the thyroid gland, as I say, you only have one of them, but it has two sides. It has a right side, which is the one I'm drawing here. So I'm drawing it from the front, and of course we're always talking about the person we're looking at, right and left, so this would be the right side. Okay, and then there is a small connection between the right side and the left side, and here I'll try and get it as symmetrical as possible. This will be the left side. Okay, right, so just a bit of terminology then now. The two halves of this are known as the lobes, so this would be the right lobe of the thyroid gland here, and this of course would be the left lobe, and I won't bother labelling that up. Okay, and then this little stalk that connects the right lobe and the left lobe, this is known as the isthmus. Isthmus just refers to narrowing, so you will call this the isthmus of the thyroid gland, which just means the narrowing of the thyroid gland. So this little bit here is the isthmus of the thyroid gland. So those are really only that's all really you need to know about the macro or gross anatomy of the thyroid gland. You have a right lobe and a left lobe, and they're connected by the isthmus of the thyroid, and that it's sitting in front of the thyroid cartilage. So you'd have the laryngeal prominence sort of in this position here, and then the thyroid cartilage would be sitting behind the thyroid gland. Okay, and I'll just finish this off by colouring it in to make it look more interesting. So those are the two lobes. Okay, so there's the gross anatomy of the thyroid gland. Let's now have a look at the microanatomy of the thyroid gland, the histology of the thyroid gland. So if we zoom in and in and in to the level that we can see cells, what does the thyroid gland actually look like? Well, the thyroid gland has a very interesting structure. It consists of lots of spheres that are known as thyroid follicles. And these spheres, you have cells lining the outside of the sphere. So the surface of the sphere is going to be made up of an epithelium of cells, which are going to be known as thyroid follicular cells, because the whole sphere is going to be called a thyroid follicle. And then inside the sphere you've got an empty space, well, not an empty space, but you've got a space that is going to be full of a fluid known as thyroid colloid, and we will be talking in detail about what this colloid actually consists of later. So, most of the tissue then of the thyroid gland is made up by spheres known as thyroid follicles that, as I say, the surface of the sphere is going to be made up of cells, but the inside of the sphere is going to be made up of a fluid called colloid. Okay, so if we take a cross-section then, we're only going to see a cross-section of the sphere. So we're only going to see a circle, okay? So this is what I'm now drawing, a cross-section. So what we will see then is, here is a cross-section of one of these spheres, and I'll now use the correct term, which is, they are called thyroid follicles. So the main thing that makes up the tissue of the thyroid gland is these thyroid follicles, these spheres that are all packed together. Now of course spheres don't tessellate particularly well, they certainly don't tessellate perfectly, so you will have gaps in between the thyroid follicles, and we'll talk about what's in the interfollicular spaces in a moment. Okay, but here is one of these thyroid follicles, and of course when we take a cross section, all we're going to see is a circle of cells, a ring of cells, which I'll make here, and this ring of cells forms an epithelium. Okay, so the cells in this ring are polarized in the way that they are in many other epithelia, such as, for example, the endothelia of the blood vessels, the renal tubule epithelia, the gastrointestinal tract epithelia. All of those epithelia, the cells are polarized. And what do I mean by polarized? I mean that the face of the cell that faces into the thyroid follicle will have different proteins in that portion of membrane to the portion of the membrane that faces out of the thyroid follicle. Okay, and the way that you can achieve that is by having tight junctions in between the cells, which will block proteins in the face of the membrane that faces inwards from diffusing into the portion of membrane that faces outwards. So let me now separate these up so they actually look like cells rather than just one confluent blob here. Okay, so this is the ring of cells then that are forming the surface of the thyroid follicle, and of course we're just seeing a cross-section of them. So I might just give them nuclei to make them look more like cells here, and as I say, they are forming an epithelium here where they are polarized effectively, so that the portion of their membrane that faces into the center here, the space where the colloid is going to be different from the portion of the membrane that faces outwards. Okay, so they'll have tight junctions in between the cells to separate the two portions of the membrane here. Okay, and the portion of the membrane that faces into the lumen here, and we will refer to this now as the lumen of the thyroid follicle, this is known as the apical portion of the membrane, and the portion that faces out into the interfollicular space, this we will call the basolateral membrane. Okay, and as I say, the concept of them being polarized is the concept then that the proteins that you will have in the basolateral membrane will be very different from the proteins that you'll have in the apical membrane. Okay, so these cells then, and I'll just colour in an example here, so we'll have this one in vivid pink here. These cells are known as thyroid follicular cells, or we could just call them a follicular cell. So these are the follicular cells, and they're making the surface of the sphere that is a thyroid follicle. Okay, now let's actually colour in the stuff in the centre, in the lumen of the thyroid follicle then. So let's have this in orange here. So this is going to be the thyroid colloid. So in the lumen of the thyroid follicle you're going to have a very proteinaceous fluid, and we will find out the major component of this fluid later on. And this proteinaceous fluid is then called thyroid colloid, and we'll just call it colloid. Okay, so in the centre there you've got the lumen of the thyroid follicle full of colloid. Right, so I think that's pretty much all I want to say at this point. So here is a cross-section then of a thyroid follicle, and you would have loads of these. This is the main bulk of the tissue of the thyroid gland. You're going to just have loads of these. So imagine if I had some fancy computer system now, I would copy this picture, stick another one here, copy it, stick another one here, copy it, stick another one here. So you're going to have thyroid follicles all over the place. All that I need to discuss now is what's in the interfollicular space. Well, of course, the major component of the interfollicular space is just going to be connective tissue holding the thyroid follicles together. But there are also going to be some other things in the interfollicular space. Oh, and by the way, just before we move on to the interfollicular space, let me just say that these thyroid follicles, these are the things that are actually involved in producing T3 and T4, and I'll talk about what those are in a moment, but they're the main thyroid hormones is all we need to know for now, and then secreting it into the bloodstream. Okay, so this is the major apparatus of the thyroid gland. Now, one thing, therefore, that you're going to have in the interfollicular space is going to be blood vessels. So I'll just draw a little blood vessel on here. So let's have, let's say, a venule here. Okay, so I'll give it a basement membrane, which I'll put in green here. And then here are the endothelial cells, like so. Okay, and of course, because we're dealing with a venule, if it's small enough, it's not going to have any smooth muscle cells surrounding it, so it's got that nice, simple structure there. So this is just meant to imply the fact that, you know, there are blood vessels in the interfollicular space, small little blood vessels amongst the thyroid follicles, and these will be collecting the thyroid hormones that the apparatus of the thyroid is secreting. Okay, the final thing to talk about that's also in the interfollicular space is the cells which secrete the other hormone that the thyroid secretes. So we've talked about the fact that there are the major thyroid hormones, the ones that this video is all about, T3 and T4. And I'll write down their names just so that we have them down. So T3 and T4, and I'll give you the full names for those in just a moment. Okay, so these are the major hormones then that the thyroid secretes, and collectively we will call those the thyroid hormones. So the thyroid hormones are these two here. Okay, but there is also another hormone that the thyroid secretes, which we're not going to discuss at all in this video, we're just going to mention it, which is calcitonin. And calcitonin, as the name implies, is involved in calcium homeostasis, blood calcium homeostasis, and it's involved in taking blood calcium level down if it goes too high. Now, in the interfollicular space between the thyroid follicles, you are going to find, along with blood vessels and connective tissue, also the cells which release calcitonin. So I'll draw one of these here. So let's just have a little cluster of them here. Okay, so these can be cells that are going to release calcitonin, and these have two names. You can either call them parafollicular cells, which is kind of a boring name for them, just meaning, of course, parallel to the thyroid follicles, or you can call them C cells, and C, of course, is because they release calcitonin. So I'll colour these not in pink, because I coloured the follicle cell in pink. What colour shall I have? I'll do them in yellow. Okay, so here are the parafollicular cells within the interfollicular space here. Okay, and these secrete the other hormone that the thyroid gland secretes, which is calcitonin, which we're not going to discuss at all. Okay, and indeed, that will be the end of my discussion of calcitonin. So here are these cells, histologically, that do secrete calcitonin, but very little is actually known about the role of calcitonin, so there isn't really that much to discuss, so I don't feel that much guilt in just sweeping this under the carpet. So let's now go back to T3 and T4. So that's the histological structure of the thyroid gland covered now. Loads and loads of thyroid follicles with connective tissue in between them, a blood vessel plexus everywhere, and also in the interfollicular space some of these parafollicular cells or C cells which release calcitonin. Now let's talk about the thyroid hormones. And when I say the thyroid hormones, we will not be referring to calcitonin, we will just be referring to T3 and T4. And often a way of writing the thyroid hormones quickly is just to put T3/T4, meaning either T3 or T4, because effectively these two things do the same thing. Okay, they are effectively the same as far as the body is concerned. T3 is more powerful than T4, but they do the same thing. Okay, and we're going to see what I mean by how similar they are throughout the video. Okay, so we're going to start off by talking about their proper names, their full big names. We're also actually going to do their chemical structures because they're very small molecules. They're not great big proteins, they're actually just a single amino acid, each of them. A non-protenergic amino acid, and we'll see exactly how they're synthesized from protenergic amino acids. But they are still just an amino acid, so they're a very small molecule. And they're both based on the amino acid thyrionine. So before I show you the structure of T3 and T4, I'm going to start by showing you the structure of thyrionine, and then of course we'll discuss in basic what they do in the body. Okay, so to start with, before I can show you the structure of T3 and T4, I want to show you the structure of a molecule called thyrionine. And in fact, T3, its full name is triiodothyronine, and T4, its full name is tetraiodothyronine. In fact, they have even longer names than that, but I will show you those in a moment once we've done thyrionine. So, thyrionine then, it's going to be an amino acid. It's not one of the 20 that's used in proteins, but it still is an amino acid with the classical amino acid structure. So it's going to have an amino group here. So firstly, let's just recite off the core amino acid structure. Here's the amino group, here's the alpha carbon, and here's the carboxylic acid group. So I hope you're very familiar with the core amino acid structure. So now all we need to do is have a look at the R group of thyrionine. So the R group of thyrionine involves 2 benzene rings, a bunch of oxygens, and also a methylene group. And we will see exactly where this comes from. So initially this might look a little bit unmotivated. You won't know what the significance of this R group is, but you will see that later on it's actually synthesized from 2 tyrosine R groups. So initially when you look at this, look at the similarity between this and a tyrosine R group. And in case you don't remember the R group of a tyrosine residue, I'll just put it up here, so a little aside here. The R group of a tyrosine residue, and I think actually I'll just draw out the structure of tyrosine in full here. So the structure of tyrosine, once again, let me just copy out the core amino acid structure. So here's the amino group, here's the alpha carbon with a hydrogen, here's the carboxylic acid group. Tyrosine, of course, is a protenergic amino acid. It is used in the production of proteins. It is put onto tRNAs and then used in the translation process. Okay, so you have a methylene group, then a benzene ring, which I'll just show like so, and then an alcohol group coming off like so. So this is the structure of the tyrosine amino acid. Now let me show you thyrionine, and hopefully you'll see the similarity of this to tyrosine, and you'll see later on how we actually synthesize thyrionine from 2 tyrosine residues. Okay, so we have a methylene group then. We then have a benzene ring, so this is all looking very similar. Okay, we then have an oxygen, but then not a hydrogen attached to it anymore. We're going to have more. We're going to have another benzene ring attached on here, like so, and then an alcohol group there. So effectively what we've done is we've taken 2 tyrosine residues, chopped this end portion of the R group, the benzene ring and the alcohol group, off one, and stuck it on the end of another tyrosine residue to create thyrionine. And as I say, this is not a normal amino acid. This is not one that you would put in proteins. I.e. in the translation process. You'd have to modify residues, tyrosine residues in the protein that you've already put in to actually create thyrionine in proteins. Okay, so this is the amino acid thyrionine then. So T3 and T4, the thyroid hormones, are going to be based on the structure of thyrionine. Okay, so we'll start off by discussing T3 and then we'll discuss T4. But in fact, before we actually go on to that, let me just give you a little bit more nomenclature concerning the carbons of thyrionine. So we're going to see that T3 and T4 are just modified forms of thyrionine. They're going to be thyrionine molecules with a few iodine atoms stuck onto them, bound in certain places. Now, to understand the naming in full, we need to know how the carbons of these two benzene rings are named up. So this first benzene ring of thiorenine is called the A ring. This second benzene ring of thiorenine is called the B ring. So that's all very simple. And now we number up the carbons in these benzene rings in a certain way. So starting with the A ring, this carbon is referred to as number 1 here, that's perfectly sensible, and then we just go round. This one's number 2, this one's number 3, this one's number 4, this one's number 5, and this one's number 6. Then with regards to number B, or the B ring here, you might think it would be sensible to do 7, 8, 9, 10, 11, 12, but that we don't do that. Instead we do 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, and then 6 prime. Okay, so in order to understand the full names for T3 and T4, we're just going to need that little numbering system then for the carbons of the benzene rings, thiorenine. Okay, right, so let's begin then with the structure of T3. So, start off with the full name for T3 then. So T3, its full name is 3,5,3' triiodothyronine. So triiodo, which just means 3 iodines onto thiorenine. Okay? And usually people don't refer to it as 3,5,3' triiodothyronine, they would just call it triiodothyronine. So more commonly you just hear this referred to as triiodothyronine. These numbers are clearly just telling you where the 3 iodine atoms are actually attached to. Okay, so there is the full name for T3 then. So all we're going to do then to thiorenine, to turn it into T3, is stick 3 iodine atoms onto the structure of thiorenine. So iodine, you know, it's an atom. It's in the group 7 of the periodic table. It only needs to form 1 covalent bond then to get up to its full number of electrons. So, what you can do is you can add them onto the benzene rings. Now remember, benzene rings, normally the carbons of a benzene ring will have a single hydrogen attached to them. Okay, so of course these two, 1 and 4, won't have hydrogens attached to them because they're instead bound to the oxygen and the carbon in this case. But 2, 3, 5 and 6 will have a hydrogen atom each attached to them. So what we're going to do is we're going to take the hydrogen off carbon number 3, and indeed carbon number 5, and indeed carbon number 3' here, and instead we're going to bind them to iodine atoms. So let me now draw out the structure then of 3,5,3' triiodothyronine. So here is the amino group, here is the, running out of space, the alpha carbon, here is the carboxylic acid group, and now the interesting bit, the R group. So here's the methylene group, and now here is our A benzene ring, but now we're going to have an iodine atom, which is just given the symbol I, coming off carbon number 3 and carbon number 5, nicely symmetrical there. And then we're only going to have 1 iodine atom now added onto ring B here, and it's going to be off carbon number 3. And by the way, there is absolutely no difference between, carbon number 3'. There is absolutely no difference between 3' and 5'. They are utterly symmetric. We just use the lower number rather than calling this 3,5,5' triiodothyronine. You would be correct to say 3,5,5' triiodothyronine. It's just it's not the done thing. We always go for the smallest number. Okay, so there is the structure then of T3. Okay, so that's T3. We'll come on to what it does in a moment. Let's firstly introduce T4, because T3 and T4 are going to do the same thing. Okay, so firstly let's just introduce T4, and then once we've got both of them we'll talk about what they do. So T4, its full name would be 3,5,3' 5' tetraiodothyronine. So tetraiodo, and we're running out of space. It would all be one word again. Tetraiodothyronine. Okay, so in the ideal world, the paper would go on, and that would all be one word. Right, so now you understand why one is called T3 and one is called T4. The number that you have subscripted after the T is just referencing how many iodine atoms you've got attached onto it. So it's threonine with 3 iodines, threonine with 4 iodines attached. Okay, and hopefully you should be able to draw out this structure for yourself, but I will do it in just a moment. Usually the name that people use for T4 is not tetraiodothyronine. Instead, people use the name thyroxine, which is the old name that someone long ago gave it, and which has stuck. So T4 is usually referred to as thyroxine. Okay, so now let me just draw out the structure then for completeness, although I'm sure you can do this on your own. Here is the core amino acid structure, the amino group, the alpha carbon, the carboxylic acid group. Here is the beginning of the R group, so we've got the methylene group, then the A benzene ring, and we're going to have an iodine again of the 3rd and the 5th carbons, okay, of that A ring. Then we're going to have the oxygen linking us to the B benzene ring here, which is now going to have iodines off both 3' and 5', and we'll still of course have that alcohol group here. So this then is the structure of T4, which in full would be 3', 5', 5' tetraiodothyronine, but the name that we will use throughout the video is thyroxine. So these are the two names that we will be using for T3, triiodothyronine, and for T4, thyroxine. Okay, so they are very similar atoms, they're very similar molecules. The only difference is that triiodothyronine has 1 less iodine than thyroxine. Thyroxine has an additional iodine coming off the 5' carbon, whereas triiodothyronine clearly has a hydrogen still coming off that. As far as their physiological relevance is concerned, they are both secreted by the thyroid follicles of the thyroid gland into the bloodstream. You have both of them in your bloodstream. More T4 than T3, as we'll discuss later, so T4 is secreted much more than T3. I think it's about 90% and 10% are the ratios. So you've got more T4 in the blood than T3, but T3 is stronger than T4 as far as its actual effect at different tissues is concerned, but they both have the same effect, it's just this one's more potent than this one. In addition, at tissues, T4 can be converted to T3. So overall, these two hormones are both secreted from the thyroid gland into the bloodstream, and they're going to both have effects at peripheral tissues. And what is the overall effect of these thyroid hormones then, which is the collective name for both of them? Well, it is to overall maintain basal metabolic rate, which we will be abbreviating down to BMR. And let me just make sure this is visible. I'll move it up a little bit. Okay, so their overall role is to maintain basal metabolic rate. And this is a really important concept that I want to get straight across right in this first video. The thyroid gland is secreting thyroid hormones T3 and T4 continuously. It's not like many other endocrine systems where you get some sort of stimulus and then the gland releases a huge amount of the hormone all at once, and that has some sudden effect that changes something. Okay, examples might be the adrenal gland releasing adrenaline during a fight or flight situation. Okay, it's not like that with the thyroid gland. The thyroid gland is just releasing thyroid hormone all the time, and we'll see that it's controlled very intricately by the hypothalamic pituitary thyroid axis, so that it will release an amount of hormone that is relevant to trying to maintain the amount of hormone in the blood at a constant level. So the idea is that you don't want fluctuations in the amount of T3 and T4 in the blood. You want it at a constant level all the time. Okay, and the hypothalamic pituitary thyroid axis is about controlling the amount of T3 and T4 that the thyroid is releasing, so that it releases a relevant amount into the bloodstream to try and maintain the same level. So if, you know, the level is quite high in the blood, then you'll slow down the amount that you're releasing from the thyroid gland, whereas if the level's dropping a little bit, then you'll increase up the amount of secretion to try and keep overall a level amount of thyroid hormone in the bloodstream. Okay, so it's not a fluctuating hormone. These are not fluctuating hormones in the bloodstream. They are just a constant. They're at a constant level, and they're having a constant signaling effect all over the body. And their role, therefore, is to maintain basal metabolic rate. Okay, they keep the body functioning normally, basically. And if their levels do fluctuate, that causes abnormalities, which you'll be able to predict once we've discussed all of the effects all over the body. But overall, what they do can be summarized as maintaining basal metabolic rate, which means maintaining how much chemical reactions are occurring all over your body, maintaining how much fuel, so sugars, carbohydrate molecules, fats, what other fuels can you have? Sugars, fats, proteins, amino acids, all of those sort of fuels, controlling how much of those fuels you are actually burning. Okay, so how many you're actually using up. And it keeps it at a constant level. So if for some pathological reason thyroid hormone level within the blood was to go far too low, then that would lead to basal metabolic rate dropping, okay, below what it should be. Okay, so you would therefore not be using as much fuel. You wouldn't be. You'd limit all of the chemical reactions all over the body, which we'll discuss in much more detail later on. If for some reason thyroid hormone levels in the blood were to elevate far too high, then that would drive basal metabolic rate through the roof. You would be consuming fuel at a pathologically high rate. Okay, so the huge message here is that thyroid hormones do not physiologically fluctuate. They only fluctuate in the bloodstream due to pathological reasons, really. Okay, so that's the basic introduction then to the thyroid gland completed. In the next video, what we'll do is begin our in-depth discussion, and we'll start by going over the in-depth mechanism by which thyroid hormones are actually synthesized by the thyroid follicles, and of course we'll understand then what the thyroid colloid actually is.